I'm really having fun with Survivor. This is the last time we're going to do Survivor. So if you were really interested in it, this is the last time we're going to do it. We're going to do Survivor, Factorial, and ANOVA. Alright, so we're changing it a little bit though. We're not totally leaving PG, but we're adding in some more things. Okay, so was there a difference? Okay, this is not a completely randomized design at all. Okay, because it's not an experimental design. Okay, so it's not completely randomized, it's not a randomized block, it's not a factorial, but we still can use those ANOVA techniques to be able to answer these questions. So the question was there a difference between the average market share based on location, and I have 3 locations, Fiji, Samoa, and Nicaragua. Okay. Changing our scenario a little bit. A difference between the average market share, so what type of analysis would I do here? A one-way ANOVA. Right. I have 3 locations, so I can't do an independent t-test. So I'm going to do a one-way ANOVA. So I can look at my results. I have my means. As far as the market share goes, we're going from 8.4% to 9.9%. Maybe a difference, may not be a difference. If we look at our variances are different. And we want to check this, but again, kind of like our independent t-test, even if we violate this assumption, it's not that big of a deal. Okay, we talked about what a type 1 error would do in this case. And all it's going to say is, well, we'll just overestimate our results a little bit. It's not that big of a deal. But we still want to check. So our analysis of variance results, is there a significant difference between our locations? Yes. Okay, so between our locations, is there a significant difference? Assuming an alpha of 0.05, yes, there is. Okay. So our null hypothesis is that they're all the same. Our alternative is that at least 2 are different. So which 2 do we know are different? So we know Fiji and Samoa have to be different. Okay. What about Nicaragua? Do you think it's different? Or? This is a little bit harder, right? Yeah, maybe, maybe not. Okay. So this is where, oh, and I have this all written down for us. So our test of homogeneity of variance, we've got that, we've got that, we've already done this. You already told me that. Yes.
Can you go back to the previous slide? One more. Yeah. So here, we see that the mean is 8.4 and the standard deviation is 3.08.
Yes.
So that means for within 95% it is going to be 8.4 plus 3.08, right? One standard deviation away from the mean.
So 68% of the data would fall within that, yes.
So if you add that, then even Nicaragua, Samoa, everything is within that range. So how come there's a difference?
So you can't just add one standard deviation onto it to actually get the confidence interval, right? Because the confidence interval has a little bit of a different calculation. Because you have to divide by, like you have your critical value, you have to take the square root of the standard deviation divided by the sample size. So you have to let all that
Just
play.
trying to understand it visually, but anyway.
Yeah. Just using those 2 values will work. The only thing that'll help you with is you can look at the mean standard deviation, will help you look at the outliers. It won't help you for like the overlapping confidence intervals. But yeah, so I mean your point being made though is that Fiji does have a wider standard deviation than Nicaragua and Samoa. Right? So that's playing into it a little bit, and that's why our variances are a little bit different. And so that's why we're finding a difference between our groups. So then our question becomes, which ones? And so here, this is our least squared differences. Right? This is our Fisher's least squared difference. And it's actually kind of nice because it tells you that it's controlling the comparison-wise error rate. Right? So alpha of 0.05 isn't alpha of 0.05 at every time. We do find out that Fiji and Samoa are the only 2 that are significantly different. we have our test, and they basically look the same, right? It calculates difference between means. The difference between Samoa and Fiji is 1.5. Here, again, Samoa and Fiji, the difference is 1.5, but here we've got two keys, and it's just controlling the experiment-wise error rate. So it's just a different test you can use. Neither one is better or worse. You'll just find your favorite and use it. Yes?
Why does sometimes two keys use letters in different steps?
I have no idea. I thought I had an idea, and I thought if you just have 3 groups, then it used letters, and if you had 4 or more groups, it used stars. But here we have 3 groups, and it uses the star. I have no idea. And there isn't an option where you can say, hey, display like this. There isn't one. It's just whatever SAS is in the group. But yeah, I have no good reason for that. The thing that you will see that's a little bit different between the least significant difference and 2 keys is the confidence limits. Okay, because least significant difference is using a t-test, it's using a t-distribution. 2 keys is looking at it a little bit different. Right? So the confidence intervals are a little bit different, but the idea most of the time, not always, but most of the time you're going to get the same results. Not always, but most of the time. So what do I analysis of variance? There is a difference in location. Samoa and Fiji are different from one another. There we go. So then, yes.
Sorry.
No, go ahead.
On our homework, do you want, or I guess just all the time, do you want us to do the analysis of engineering?
You don't have to. You don't have to show it to me. Should you look at it? Yes.
Okay, but we don't have to show it to you.
You don't have to do it. You don't know. Not unless I specifically ask for it. So if you want to, you're welcome to. But I'm not going to count off points if you don't have them. So our next question was there a difference between the average market share based on the original tribe composition? Right? They've been going for 37 seasons. They've had to mix it up a lot of different ways. And the ones I looked at, you can either have 2 tribes of 9 or 2 tribes of 10. Okay? They did a lot of other compositions, but these worked best to make our analysis work. So we have 2 tribes of 9, and we've got 5 seasons for that. 2 tribes of 10, we've got 6 seasons for that. So now I just have 2 seasons, or 2 different types of tribes. Do I have to do an analysis of variance? If you really love your t-test, you can default to a t-test here. Okay. Or, if you're like, I never want to do a t-test again, you can always do an ANOVA. So here I went ahead and stuck with the analysis of variance. So here we have a mean of 8.9. If you have 10 people, and a mean of 9.4, 9.5 if you have 9 people, 18. Think that's going to be different? Probably not. Let's find out. Our p-value is 0.1309. Not a difference. Okay. So there's not a difference between the tribe composition, but there is between the location.
So when you're comparing 2, we can still use ANOVA provided they are independent.
Yes.
If they're dependent, we can't.
Technically, if they are dependent, you can do a thing called a repeated measures ANOVA, and yes, you can. But there's some different buttons we have to click. But yes, ANOVA works for repeated measures and dependent as well. Yeah. Really, anything you want to do, you can use the analysis of variance for. Well, tease into, so next week we're going to leave hypothesis testing, and we're going to move into prediction with regression, and actually an analysis of variance and multiple regression tie hand in hand. So like there's some math you got to do, but you'll start to notice, and I haven't emphasized this, but like we have this r squared, and we have this coefficient of variation, and we have this root mean squared. Some of these things you're going to see on our regression output We get it in the ANOVA table for our regression output. So yeah, you can do it in ANOVA. So we already decided we're going to fail to reject. So our variances are equal in this case, and there's no significant difference between our triad composition. So then here comes the next question, what we've been leading up to, is there a difference between the average market share based on location and the original tribe composition? Okay. So location alone, yes, there's a difference. Tribe composition, no, there's not a difference, but is there an interaction? Okay. So let's look. So I'm going to show you the results, and then I'll show you how to get it on SAS, and then we'll take a break. So here we're comparing multiple means with multiple independent variables. The way this table is set out, okay, what you're going to be looking at, if you decide to pursue this, here we have the model. And here we have the details. Okay, so instead of putting, so when I had the example, right, I had all of this in one table. Here, SAS likes to put it in different tables. So it summarizes all the information for the model. We're going to focus on this bottom information, on this, what we're going to call the type 3 sums of squares. Our type 3 sums of squares, doesn't matter the order in which you put location versus tribe composition or tribe composition versus location, it doesn't matter. It's just going to evaluate our type 1 sums of squares or type 3 sums of squares. So the model breaks down, like I said, into location, tribe composition, and location times tribe composition. So the first thing we want to look at is there an interaction? So we've got 3 different things we're going to look at. We're going to look at, is there an interaction, is there a factor A effect, and is there a factor B effect? Okay, so the first thing we're going to look at is there an interaction? So our null hypothesis is that there's no interaction. Our alternative hypothesis is that there is an interaction. If we look at the F value, it's going to be 275. It's really, really big, which means our P value is going to be really, really small, which means there is an interaction. And we're going to reject our null hypothesis, and we're going to conclude that there is a significant interaction. The graph to the right, this is what's illustrating. This is called an interaction plot. On our far left, we have Fiji. And so the dots are just the data points, or a summation of the data points, and a lot of the data points are very similar in this case. So on the far left we have Fiji, in the middle we have Nicaragua, and on the far right we have Samoa. Okay, so you can kind of see how some of the lines are broken out here. Some of the data points are much more spread out for Fiji than they are for Nicaragua and Samoa. The other thing you'll notice is that the red line is when you had 9 people on a tribe. The blue line is when you had 10 people on a tribe. So for Fiji, which tribe composition had the highest market share? 9. But for Nicaragua, which tribe composition had the highest market share? 10. And for Samoa, which one had the highest market share? 10. So we just said that on its own, tribe composition didn't matter. But when you add in the location with the tribe composition, now it does matter. This is where that interaction comes in. But depending on the order in which you enter this into SAS, you can get an interaction plot that looks like this, or like this. And so here we have the tribe composition, so 10 people on a tribe on the far left, 9 people on a tribe on the far right, blues for Fiji, reds for Nicaragua, and green is for Samoa. The interaction occurs when the lines cross. So if the lines are crossing, then there is an interaction. And again, we'll notice that Fiji is the one that's different. If we took Fiji off, we've got Nicaragua and Samoa, things should be just fine. There shouldn't be an interaction. But if we keep Fiji, it's doing the opposite of what the other two locations are doing.
So what seasons were those, though?
So does the season matter? It could. We're not going to look into that right now, because then that's going to mess up my server. I was on a Survivor thing. I had to find some. This is what you do not do, okay? You do not find the data that answers your question. This isn't exactly the P happening, but it's very cool. But it illustrates, it's great teaching. It's illustrating exactly what I want to illustrate. Yes, so remember Fiji, season 14 was kind of higher than everything else. And the rest of these are 19, 20, 30s. That's what the difference is. It's really more season than composition, but yes.
So, ignoring the season part.
Yes.
What is it saying?
What is it saying? So that's the question, right? So, if I would have just started out and just answered the question, is there an interaction between tribe composition and the location? Right? That's really what I'm asking. Okay, is there an interaction between the tribe composition and the location? Yes. Yes, there is. Okay? So what it's saying is that, and this is why I did both of these pictures, because sometimes one's easier to interpret than the other. Right? I kind of like this one a little bit better for this interpretation. Because what I'm seeing is that the tribe composition, so for Nicaragua and Samoa, right, if you had 10 people on a team, you had a higher market share than if you had 9 people on a team. For Fiji, you saw the opposite. If you had 9 people on a team, you had a higher market share than if you had 10 people on a team. And so this is what I was talking about. When you have a significant interaction for this class, we're just going to stop. And we're going to talk about what do you see. We're going to talk about, it's like, yes, there's an interaction, and this is where I'm seeing the interaction. This is what's happening. Right? So whether you use this picture or this picture, you're still getting the same idea that something's happening in Fiji. Okay? So in Fiji, you had lower market share for when you had 10 people on a team or 10 people in a tribe, and higher market share when you had 9 people in a tribe, which is the opposite of what happened in Nicaragua and Samoa. And that's what we say.
Does the thickness of the circles, does that mean anything? Some of them look thicker than others.
Yeah, so the thickness of it is basically saying, here's 12.4, 12.4, 12.4. There's a lot of 12.4s. And then, oh, here's, I don't know, at the top over here, 14 point something. Yeah, so the thicker the circle, the more values you have right there. Absolutely. So that's what happens if we have an interaction. If we have an interaction, we're just going to stop. Okay. But, again, I like to illustrate things the way I want them to be, and I can track my data and such. So now let's take out Fiji. Fiji seemed to be our problem child. Right? So Fiji was our problem child, so let's get rid of Fiji. So we got rid of that season 14, it's kind of problematic. 33, 34, 36, Fiji's gone. So now we're just looking at Samoa and Nicaragua. We have 2 tribes of 9, we still have 4 seasons for that one. We've got 2 tribes of 10, we still have 3 seasons there. So we've got plenty of data that we can play with. So, goodbye, Fiji. So now, same idea. We still have our model. This is what we're looking at. And we're going to look at the interaction and is there differences between our groups. So I'm going to take this one at a time. So step 1, is there an interaction effect? In this case, our p-value is 0.1892, so is there an interaction effect? No, right, so this one's greater. So we're going to fail to reject our null hypothesis. So there's no interaction. Here, looking at our interaction graph, none of our lines cross. Okay. So this is illustrating that there's no interaction. So whether you look at it from this perspective or this perspective, in both cases, the interaction doesn't happen. Okay, so we don't have a significant interaction. So that means we get to move on to check factor A and factor B. Okay, is there a difference in tribe composition, and is there a difference in location? So again, now that we're down to 2, we could actually do a definity test, but we're not going to because we like ANOVAs. So for factor A, Okay, our factor A was location. Let's go back to our output. So this is factor A, factor B. For factor A, we're looking at our location. Our F value is 6.76. Our P value is 0.01. So what are we going to conclude? We're going to reject our null hypothesis. So location does matter. We can actually go back and look, and we find out that Samoa has a higher market share than Nicaragua. So that's where these things come in. So Samoa, actually let's look at it this way. Samoa is our red line. It has a higher market share than Nicaragua does. For factor B, we're going to look at the tribe composition. P value is littler. We're going to reject our null hypothesis. We're going to say that factor B does have an effect. There's a significant difference between our tribe composition. If we go back, we can decide. Let's look at this one. Our blue line's higher. So if you have 10 people in your tribe, you have a higher market share than if you had 9 people in your tribe. So teams with 10 has a higher market share than teams with 9 for tribes. Questions, comments? Yes. So lots of them. Yeah.
So really, the only difference about this test is the interaction part. This is just you can test on your own. Like you can test each factor.
Yeah. Okay. So you could do it. You can do factor A. You could do factor B. The point behind the factorial ANOVA is to do factor A and B together.
And then you can do the other two.
Yeah.
I don't know if I missed that. Why are you doing type 3 instead of type 1? You're using the type 3 table instead of type 2 table.
So the type 1 sums of squares are sequential sums of squares. The type 3 sums of squares are not. And so general practice, and if you actually went to general practice is just to use the type 3 sums of squares. Because here, if I put location and then tribe composition in, we have a certain order. And then if we do tribe composition and then location, then we'll have a different p-value. Most of the time, your decisions are going to be the same. So it really just depends on, because all you're doing is you're just breaking up the error. That's really what we're trying to do. And you're just distributing it in different ways. This is just our standard practice of what we use the majority of the time. So, take your experimental design class and you learn all sorts of stuff about it. But yeah, the difference is just if it's sequential or if you just kind of have it all together. And then order doesn't matter.
The second thing is this question about episodes, where the season doesn't matter. So I was thinking, in case it needs to be done, we could probably do a block ANOVA, right? For each 9 into 10 and 10 into, teams of 9 and teams of 10 you can have for each season. And then to actually compare them, we can have a block based on whether it's Nicaragua or Fiji or...
So the difference that happens there is, I'm going to have to look. I don't know if we can block a factorial ANOVA. I mean, I feel like you should be able to, but I don't know how you would make that happen in the software. I have to think about that one. Conceptually, it makes sense that you could, but I just don't know how to do it. So, 35 more minutes. I'll show you how I got these results in SAS, and then we'll go take a break. So in SAS, I'm going to open up my survivor data. And this is SAS tutorial 6C. So if you guys are going through the tutorials, that's what this part is. And I'm going to select my survivor ratings data. I'm going to assume it's all on sheet 1. So it's very incomplete data, just because I find the data I want to illustrate the point that I want. But so what we're going to do, we want to just do an ANOVA, just the one-way ANOVA. Right? You can go to a one-way ANOVA. We select our dependent variable, which in this case is our market share. Our independent variable, which is our grouping variable. So I'm going to do location. The test that we're going to run, I choose the Levine's test. You can choose any or all of these to do our homogeneity of variance. Here I can choose Tukey's standardized test range. Range test. Or you can do Fisher's least significant difference test. One of your options on ISYS for kind of your choose your own adventure is you can actually pick any of these and research them a little bit and just tell me about them. Just in case that's something you're more interested in, you can dig a little deeper there. I'm going to go ahead and add the box and whisker and my means. I'm going to run this. And so here I didn't filter anything out, so I have Australia, Fiji, Kenya, Malaysia, Nicaragua, Samoa. So I have all sorts of information. Fiji looks really crazy here, comparatively. Okay. So that's how we do a one-way ANOVA. The next that we have is what if I wanted to change this into the results that I had? Okay, so I'm going to do a filter just to make things a little bit easier so we don't have some of this crazy stuff happen. I'm going to go back to my data. I'm going to filter and sort. I want to keep all of my variables. I'm going to filter, and this time I'm going to filter by location. I'm just going to keep the location that I want. Yes.
So in server with that, I think data which I'm seeing has got only Malaysia and Fiji. Choosing some other data.
I chose the survivor ratings data.
Let's do the Excel.
I'll do the Excel.
Oh, do the Excel. Yes. Yes, thank you for that. Yeah, you have to do the Excel because I've updated the Excel and I haven't pushed it out to the SAS table yet. Sorry about that. So here I'm going to go to location, and so you could go to location is equal to, or location is equal to this, or location is equal to this. Another option, and we haven't really done this, is you can put it in a list. So here I'm going to do location in a list, and then you can go down to this, so you like click on the little ellipsis, and it pops open, and you can actually type in the values that you want, or you can go down to add values, and you can select the values that you want. So in our case, I'm going to do Fiji. I'm going to hit Control so I can select multiple things. I'm going to do Nicaragua and Samoa. I'm going to click OK. So it kind of pastes. So I could have just typed these in and it would have been fine. I'm going to click OK. And so now, instead of just doing this or this or this, now I have them all on the list. So the same thing is accomplished, just different ways to do it. Because I want to do tribe composition, and you'll notice right here, season 35 was missing for Fiji because it didn't fit in the 2x2 or 2x10 or 2x9 scheme. I actually want to go ahead and get rid of season 35. So I'm going to just modify my task. So when I filter, I want these locations, and in this case I'm going to do and. I want my season that is not equal to, in this case, season 35. So I should have Fiji, Nicaragua, and Samoa, and all the seasons that aren't 35. Okay, so as you're filtering your data, make sure that you have an idea of what you want it to look like, and then go back and spot check before you start doing analysis with it, okay? So there we go. So that's the data that I want. And now I'm going to analyze this data. I'm going to go to ANOVA. But I'm not interested in doing a one-way ANOVA anymore. Now I'm going to do a factorial ANOVA. So to do a factorial ANOVA, we're actually going to go down to linear models. Because what we've been doing has been generalized linear models. We can do a lot of stuff here. So the data that we're going to use, the dependent variable, the thing that our outcome that we're looking at, is still going to be share, or market share. And the classification variables I'm interested in are location and tribal composition. The model that we're going to create, so that's our data that we're going to use. So now the model that we're going to look at, I could do a randomized block by just selecting location and tribe composition. But I want to do a factorial, so I'm going to select both location and tribe composition. So you may have to hit Shift or Control to select both of those. And now you have factorial that kind of lights up right here. So if you click factorial, you're going to have location, tribe composition, and tribe composition asterisk location. So that's our interaction that we're going to be doing. That's an important part right there to set up our model. This is saying we're going to do a factorial model. As far as the model options go, since we're only using the type 3 sum of squares, we could just select type 3 and not type 1 and not have to confuse ourselves. I also uncheck show parameter estimates. This is helpful when we're doing regression. It is not helpful when we're doing analysis of variance. This doesn't make sense. Okay, so I'm going to uncheck show parameter estimates. And again, this is all in your SAS EG 6C. Stepping through it. For the advanced options, we're not going to worry about the advanced options. Again, the more you know, the more experimental design you know, all of this stuff will start to make more sense. Then we have the post hoc test. Okay, we could be doing post hoc tests. We're not going to focus on this though. So we're just going to kind of skip over the post hoc test. This is where you could actually create your own post hoc test or your contrast. You could actually type in right here. What we're going to do is we're going to go to plots. And you would think that all appropriate plots for the current data selection would be sufficient, but it's not. So we're going to do the custom list of plots, and we're going to choose the ones we want. We can do the diagnostic plots. It's just going to be a bunch of stuff that I'm not going to focus on, so I'm actually going to uncheck that. And I'm going to check interaction plot, because that's the thing I really like. And so there's a little bit more detail, right? We're going up to this factorial, we're getting more detail, we're doing more things, we have more buttons to click and check. And now I'm going to run this option. And here we have all of our information. So we have our table. So here I reduce it just to the type 3 sums of squares to look at. And here's our interaction plot. So because I did location by tribe composition, this is how we have our interaction plot. If I want to modify this task and move tribe composition above location, and run it again, the map here stays the same. No, it doesn't. Do something there. There you go. Tribe composition, location. This was not what was happening. Oh. Okay, this is a perfect example of what not to do. So when I modified the task and I moved those two things around,
You have to go back and change the model.
you have to go back and change the model. So I'm only getting one result because my model's not here anymore. So now I want tribe, composition, and location, and I want that to be a factorial. All the other options should stay the same. They don't. So I'm going to uncheck parameter estimates. My interaction plot stays the same. And now we get the same results with a different interaction. So again, this is, as far as assignment 6 goes, assignment 6, you have just one textbook exercise where you get to do an analysis of variance that includes a post hoc test. Task 2 goes back to that written communication of any kind of communication you want. Very open there. Your supplemental materials, you're basically doing 2 one-way ANOVAs. However, for a 2-point bonus, you can do an interaction. So you can do a factorial ANOVA. And then for your choose your own adventure, like I said, you can research your post hoc test, you can go play in Tableau, go to the business communications lab, or have someone of your own choosing give you some feedback.